Hello, welcome to this video on graphing polynomial functions. This is 3C lesson 1. I'm going to split this lesson into two videos. This lesson is going to focus on graphing polynomial functions based upon end behavior, so what happens at the end of a function, and then the zeros, so kind of where they intersect or what their x-intercepts are in the middle of the graph. Okay, so without further ado, I'm going to go ahead and get your prior knowledge going on end behavior. So here we have a quadratic that is reflected, and in this example you should notice that you have an end behavior that is down here and an end behavior that is down here. So again, you need to think about end behavior as what's happening to the x values, okay, so left, right, and when we have arrows, we're going to be going either to negative infinity or positive infinity, okay, and also too, we're going to be going either to negative infinity or positive infinity, okay, for our y values. So if we think about this, I'm going to make just like an ordered pair down here. Okay, if this was an ordered pair, what would the x value be and what would the y value be? Well, x values, okay, I'm going to this direction, right? My arrow's going this way. Okay, that is negative infinity. My x values are going to negative infinity. I'm going to keep increasing this way. Okay, then what's happening to the y values? Well, the arrow's pointing down, so that is also negative infinity. Okay, so if I wanted to write that end behavior statement, that would be as x goes to negative infinity, y is also going to negative infinity. Okay, the next one, I'm going to switch this over to green since I used blue for my infinities. Okay, my x values, right, aren't they increasing? So here I'm at -2, I'm at -1, I'm approaching 0, and I'm going to keep going this way forever. So my x-intercept, or my x value, sorry, would be positive infinity, and then my y coordinate would be negative infinity. It's going down. So as x goes to positive infinity, y is going to negative infinity. That is your end behavior. Okay, and we're going to be reading end behavior statements in these lessons, and then using them to graph. Okay, so when a function has more than one zero, this is called multiplicity, and this is very, very important. I would highlight this, okay? And you have two types of multiplicity. You can have even multiplicity, meaning you have values repeating an even amount of times, right? 1, 1, here, -5, 2, 2. Okay, so those are all even multiplicity. But you can still have also odd multiplicity. Now, what's the difference between even multiplicity and odd multiplicity? Well, even multiplicity, this creates a relative max or a min at that 0, and you can see this visually here. I have a multiplicity of 1, right, here and here. Okay, so I get a maximum there, and then I get also minimums here and here for these two values. Okay, so relative max and mins when you have even multiplicity. If you have odd multiplicity, it's an inflection point, which just means that it's going to pass through it, and then the concavity of the graph is going to change. We won't really see much of those examples, okay, so you don't have to worry too much about that. Here is our graphing recipe, if you will, if we're going to cook up a graph. The steps for graphing polynomials. Step 1, make sure you have an x and y axis scale and make sure it's appropriate. Step 2, you'll want to plot your zeros and then plot the end behavior and sketch from left to right. Okay, so make sure you have those in your notes, and we're going to go ahead and look at some examples. So here's the first example, and it says sketch the graph of each polynomial function given the end behavior and real zeros. So I already have a scale. If you need to draw your scale, go ahead, draw your scale. But the next thing that I have to do is I have to plot these zeros. This is what's recommended as step 2. So I have real zeros at -3, and again, real zeros, these are x-intercepts. Okay, so a 0 here at -3. I have a 0 at 1 and a 0 at 6. Now, next, what they tell us is the end behavior. The end behavior, as x goes to positive infinity, okay, so x goes to positive infinity, that's out here, y goes to negative infinity. Negative infinity is down here. Okay, so that means that at this end of my graph is going to be going down this way, that direction. Okay, as x goes to negative infinity, and I'll just use a different color here. As x goes to negative infinity, so as it's going this way, okay, y is going to positive infinity. Well, that's up here. Okay, so as I go this way, my graph's going to go up. Okay, and so that's that direction. All right, so that's end behavior. I have my zeros, and then step 4 is just graph it from left to right. Okay, so I have my function. Actually, this is kind of bad. I want to maybe start from up here. Okay, I'm going to pass through that 0. So the only time you can cross the x-axis is through that 0. And then I need to come back and pass through this one. So I'm going to turn around and pass through it. And then I'll pass through this one, and I'm going to head down here. Questions I get often are like, how did I know how to turn around right here? How did I know where the min and the max are? Well, we don't have that information. So you could, and I'll draw it in a different color. It could be something like this. We don't know. It could be something like this. Okay, we don't know. But for sakes and purposes, I drew it that way. Okay? So either way would be fine as long as you go through the zeros and you get your end behavior. All right, here is example 2. So example 2, again, I have my scale, my x and my y-axis scale, and what I'm going to do is I'm going to plot my zeros now. So -5, -3, and 0. And then my end behavior is as x, and I'll put these in different colors for you guys, as x goes to positive infinity. Okay, that's this way. Oh, we have an announcement.
Excuse the interruption. Varsity lineman, please report to room 10. Varsity lineman to room 10. Thank you.
If you're a varsity lineman, you got to go to room 10 right now. Okay, and then the y values are going to positive infinity. That's up here. All right, so my graph's gonna go up this way at that end. Okay, and then as x goes to negative infinity, y is going to negative infinity. So this direction, it's going down here. Okay, so something like that. Okay, and I'm going to go ahead and graph from left to right. So I start over here. I'm going to pass through this value, pass through this value, and pass through that value. And ta-da! There's the graph. Pretty easy, right? Okay, I'm going to go back actually just in case you weren't done so you don't have to pause it. All right, the next couple of examples are practice problems. I'm gonna put them up. Please pause the video. I want you to try them, sketch them on your whiteboards or off on the side if you have graph paper. You don't even have to have graph paper, you're just sketching, okay? And pause it, try it, and then look at the responses, okay? So here's the first practice problem. Okay, hopefully you tried this. Here is what your graph should look like. 0's at -4, -1, and 5. Okay. Oh, wait, sorry. And then your end behavior. Next practice problem. Oh, the next one's an example. I think what I'm going to do here, I'm going to pause the video. I'm going to make another one. Okay, so in this video, we talked about sketching graphs given zeros and end behavior. The next video is going to focus on multiplicity. What happens when we have zeros that repeat? All right, catch you next time.